Hi everyone, welcome to MVC. Today we are looking at general solutions, grade 12. So we have this general solution here: sine 2x cos 10 minus a cos 2x sine 10. That part, it is equal to cos 3x. So we need to determine the general solution of this particular equation. So like we had the equations on our algebraic quadratic equations, we also do have our trigonometric equations, and the method that we use to solve such equations, it is now therefore called the general solution. So which means we are going to determine all the possible values of x using our general solution method. We will be looking at the solutions focusing on different parts of our Cartesian plane, and then you will see exactly what is going to be the end product of the value of x. So let's try and work this out. We are having sine 2x cos 10 minus cos 2x sine 10, which is equal to cos 3x. Now you recall your compound identities. So as you can see on your left hand side, you have a compound identity. So that means therefore we have to change that part to its equivalent identity. So the equivalent identity of this part over here is going to be a sine into the 2x minus 10, and that part, it is said that it is equal to a cos 3x. Right, so now let's try and solve for x here. Now if you are having different trig ratios, in this case we need to apply our co-ratios. So if you apply the co-ratio here, so you can choose whether to apply the co-ratio on this part or to apply the co-ratio on that part. So I will try and apply the co-ratio here. So this will be a sine into a 2x minus 10. Therefore if I apply the co-ratio here, this part is going to be a sine into the 90 minus 3x. Okay, because of this 90, this cos has changed to its co-ratio, which is sine, and therefore we can apply the general solution method straight away from here. So this will be the 2x minus 10, which is equal to the 90 minus 3x. Right, therefore plus k multiplied by the period, whereby your k is an element of the integers. Okay, so this part of the general solution, it represents the solution in the first quadrant. So our reference angle in this case, it is the 90 minus 3x. Right, so let's try and simplify this. So this will be the 5x, and that will be the 100 plus k times the 360. Right, so the final value of x in this part is going to be the 20 plus k multiplied by, if we divide throughout with the 5, and that part over there, it will be a 72. Okay, so we said we are looking for solutions of this equation where your sign is positive. So this part over here represents the first quadrant. Okay, so now let's see where can we find the other solution of this equation. It should be on the second quadrant, because this is where your sign is positive. Right, so we're looking for the second solution that should be on the second quadrant. Okay, so now we have our 2x minus 10, which is equal to, now in order for us to represent the second quadrant, we know that it should be 180 minus. So this will be 180 minus, like I said, our reference angle, therefore plus k times the 360. We said k is our element of integers. Right, so we can try to simplify this. So that will be the 2x minus the 10, and then that will be the 90 plus the 3x plus k times the 360. Right, and then this will work out, if we simplify this further, it will work out to be negative x is equal to, what will be that, is 100 plus k multiplied by 360, and therefore we have to divide with negative 1, divide or multiply. So the final answer here is going to be x minus 100 minus k times the 360. So this will be our solution in the second quadrant. So guys, this is how you work out your general solutions. Until then, I will see you on my next video. Stay tuned.